Dear students, this is our fourth class on the chapter Laplace Transform. We have already started to solve some problems in our previous class, and the continuation will be here, and therefore in this class we will also solve some problems. So let us start. Now the next problem is here. Find the Laplace transform of fx, the function fx, which is defined as fx is equal to x by tau when 0 less than x less than tau and 1 when x is greater than tau. So this is the function fx which is defined in this way, and now we are here to find out the Laplace transform of the function. Now, since we know that the Laplace transform of the function fx is defined as that is what is that 0 to infinity to minus px, then fx function fx and then dx. So in that sense, or in from that definition, the Laplace transform of the function that is given here, that means Laplace transform of fx can be written as the limit can be divided into two parts. One is 0 to tau and another is tau to infinity. So that is a 0 to tau e to the minus px, then the function that is in this limit 0 to tau, the function as defined by this here, as defined as here, the value of the function fx should be x by tau in the limit 0 to tau. So that is here e to the minus px, then x by tau, then dx. Plus the next limit will be tau to infinity, and in this limit, that is x less than tau, that means tau to infinity, the value of fx is 1 in this case. Therefore it would be tau to infinity e to minus px into 1, since the value of the function is 1 in this case, then dx. So it is clear to all. Now we have to integrate these two integral. First compute these two integrals. First from this one, 1 by tau is there, this tau is there taken here, then integration of e to the minus px, then x dx. So you know this should be done by using the method of integration by parts, and in that case x should be taken as constant, and then integration of e to the minus px, that is equal to the minus px by minus p. The limits are 0 to tau, and then minus 0 to tau. After that you have to differentiate these x by tau, that is here the tau is taken here, so here the differentiation of x is 1, and then integration of e to the minus px is p e to the power minus x by e to the minus px by minus p, and then dx. So the value of this integral is here within this square bracket. After that this plus is there, and you know the integration of e to the minus px, that is here e to the minus px by minus p tau to infinity. So that is equal to 1 by tau is here, and now just use the limits of this integration, or compute this one first. So this is here, this is also done here using the limits 0 to tau in this expression, or in this term. So here if you use tau as the upper limit in this expression or in this term, then first tau, then e to the minus tau p by minus p, and when you will use the value of x as 0, then this will give you 0 result. So that is this integral, or this term will provide you tau e to the minus tau p by minus p. Then from here, you know the integration of this term is 0 to infinity, that means 0 to tau, that is e to the minus px by minus p, then 1 into dx. That means it is the integration of 0 to tau e to the minus px by minus p dx. So that will provide you. So first this negative sign, this negative sign will give you a positive sign, but the integration of this term will also give another negative sign, that is here, and then the integration of e to the minus px is e to the minus px by minus p, and then this p and the initial p, that will give you p square, and this negative sign is here actually, so 0 to tau, then plus e to the power, here you use the value, if you use the upper limit, that is infinity, this will give you 0 result, and then for the lower limit another minus, and this minus will give you positive sign, plus sign, then e to the minus p tau by p. So that is equal to just here the next slide is here. So this is equal, this tau will cancel each other. So the first term is minus e to the power minus tau p by p. Then from here minus, and the upper limit is tau. So e to the power minus p tau by tau p square, because you know this tau is here, and from here you have e to the minus p square, e to the minus p is the p square. So if you use tau here, e to the minus p tau, and this p square, and this tau is here. Okay, this is negative about the upper limit. For the lower limit, this will be plus, because this negative sign, and for the lower limit another negative sign will come. So plus, then if you use x as 0, so e to the power minus px will give you 1. Then this tau is here, and this p square is here, and this term is here. So this term and this term will cancel each other. Finally, you have from here tau p square is here. So the in this term there will be 1, and from here it will be minus p tau. So from this you can easily write that the Laplace transform of the function that is defined here, is given by 1 minus e to the minus p tau by tau p square. So this is the solution of this problem. Now the next one is find the Laplace transform of the following functions. Number one is x sine hyperbolic ax, then x square cos ax. So we have to compute the values or Laplace transform of these two functions. First one is here, the given function is, the function that is given is x sine hyperbolic ax. So the Laplace transform of this function is, first we have to compute, or we are here to compute the Laplace transform of the function sine hyperbolic ax. So that is there. So Laplace transform of sine hyperbolic ax, that is equal to Laplace transform of, you can write sine hyperbolic ax as e to the power ax minus e to the minus ax by 2. You can write this is the formula of sine hyperbolic ax that can be expressed in terms of exponential. So this is here. Then this half is these two, that is half is here. Then Laplace transform of e to the power ax minus half Laplace transform of e to the minus x. You can write these two terms from here. Then that is equal to half e to the power 0 to infinity. You know that from the definition that the Laplace transform of e to the power ax should be 0 to infinity e to the minus px e to the power ax dx, then minus half 0 to infinity e to the minus px e to the minus x dx. So that is equal to half 0 to infinity, from here minus p plus x dx e to the power, and then minus half 0 to infinity e to the minus p plus ax dx. You can write. This is easy to understand. It is very simple to understand. So then, therefore, the Laplace transform of sine hyperbolic x, that is equal to, just integrate this. That will give you half e to the minus p minus. You can write this in this way: minus of p minus ax by minus p minus a 0 to infinity, then minus half e to the minus p plus ax by minus p plus a 0 to infinity. And after that, just you have to use the limit, or after using the limit, you have half 1 by p plus a minus 1 by p minus a. We have computed this like this type of calculations, and therefore we are not going through the detailed one, but you can compute the detail of all the steps. You can go through all the steps. So that is here, and from here a by p square minus a square. So sine hyperbolic x is equal to a by p square minus a square. So now we have to compute the Laplace transform of x sine hyperbolic x, and you know that in this way, that Laplace transform of x to the power n gx, gx is the function. So x to the power Laplace transform of x to the power n, then gx is equal to minus 1 to the power n dn dpn, and then gp. You know this relation. And here that means gp is the Laplace transform of the function gx that is given. So our function is here, the Laplace transform of sine ax is equal to this a by p square minus a square. Therefore the Laplace transform of x sine hyperbolic x, that is equal to minus 1 to the power 1. That means this will be minus then ddp of a by p square minus a square. Now we have to calculate the value of this. So that is here. So that is here. So that means L x Laplace transform of x sine hyperbolic x, that is equal to, so we have to compute this. To do this, negative sign first will be here, and then a is constant, that is here. Then differentiation of this, that means p square minus a square to the power minus 1. So differentiation of that will give you minus of p square minus a square to the power minus 2 then 2p. That is here. So that means p square minus a square whole square and then 2p. It always it also give you another negative sign. That negative sign and this negative sign will go to a positive sign. So that is equal to 2ap by p square minus a square. So the Laplace transform of x sine hyperbolic x is equal to 2ap by p square minus a square. And now the second one is here. What is the second one? Sorry. Yeah. The second one is here. That is the given function is f(x) is equal to x square cos ax. X square cos ax. So we are here to find out the value of the Laplace transform of this function. So we are here directly we are writing the Laplace transform of cos ax. That is equal to p by a square plus p square. We know or we have already calculated or find out the value of Laplace transform of cos ax, that is equal to p by a square plus p square. And now Laplace transform of x square cos ax. You know that the general formula is here, Laplace transform of x to the power n fx, that is equal to minus 1 to the power n dn dpn fp. Fp is the Laplace transform of this function fx. So in our present case, the function is cos ax, whose Laplace transform is p by a square plus p square. So then this value should be minus 1 to the power 2, because in this case the power of x is 2. So this should be minus 1 to the power 2 according to this relation. Then d2 by dt square, and after that the Laplace transform of this function, that is p by a square plus p square. So that is equal to ddp, or dt we can write. So that means this is equal to d2 dp square p by a square plus p square. So first we are so that can be written as ddp, then differentiation of this with respect to p. That means we can write ddp of p by a square plus p square. So that is equal to ddp into first what we are doing. First we are here keeping p as constant in this term. So first p is there. After that, the differentiation of a square plus b square, that will give you a square plus p square whole square, and here also minus 2p, because you are differentiating this p square, that will give you 2p, and since the power is equal to minus 1 in this case, so that will give you a negative sign. So the differentiation of a square plus p square is equal to 1 by a square plus p square is equal to minus 2p by a square plus p square whole square. And this p is also here, so 2p square will be there. After that, this a square p square should be taken as constant, and differentiation of p is 1. So finally we have ddp of just simplify this. So a square plus p square whole square will be the denominator, and here a square p square should be multiplied by this. That is here. Okay. So then since this is a square plus p square whole square, so after simplification, here this one should be multiplied by another a square plus p square, that is a square plus p square, and then minus 2p square is here by a square plus p square whole square, that is equal to ddp of, from here, a square minus p square by a square plus p square whole square. Okay, no problem. Now we have to differentiate this. First, take a square minus p square as constant, so that is here a square minus p square is constant. Then the differentiation of this term, that will give you, since the power in this case actually a square plus p square to the power minus 2, so this minus 2 is here. Then a square plus p square to the power minus 3 will be here, that is actually this a square plus p square to the cube, and after that the differentiation of p square is 2p here. So the differentiation of these keeping a square minus p square constant is here, a square minus p square constant term is here, and the differentiation of 1 by a square plus p square whole square, that is equal to minus 2 into 2 by a square p square whole cube into 2p. After that, keep this a square plus p square whole square as constant, that is here, and differentiate this term, that will give you minus 2p. So that is here. So from here you can write these 2 and p, so 4p, since it is a square minus p square and this has another negative sign, So that can be written as 4p into p square minus a square. After that, I am simplifying here at a glance. Therefore, the denominator will be a square plus p square whole cube. So this term is here, this two term, and this term should be multiplied by a square plus p square. That is 2p into a square plus p square. That is also written here. So here the denominator a square plus p square whole cube. Then 2p is taken as common term from this. The first one is since 2p is taken here, so 2 should be multiplied these and these, that is 2p square minus 2a square. Then from here minus a square due to this negative sign, another minus p square due to this negative sign by this. Okay, that is equal to 2p, this 2p is here. Then from here p square, and from here minus 3a square by a square plus p square to the power 3 over whole cube. So the Laplace transform of x square cos ax is equal to this. So we have succeeded to compute it. The next problem is here, evaluate the expression that is Laplace transform of e to the minus 4t sine 3t by t. So in this case, we first we have to calculate the value of sine 3t. So sine 3t is here. You know that the Laplace transform of sine x is equal to a by p square plus a square. So in this case, this a is actually 3. So therefore Laplace transform of sine 3t is equal to a by p square plus a square. That means 3 by p square plus 9, and it is a p that can be written as, which is the Laplace transform of sine 3t. After that, we are here to compute the value of Laplace transform sine 3t by t. It is actually in the form 1 by t sine 3t. That means 1 by x fx. So this is in this form. And I know that the Laplace transform of 1 by x fx, that is equal to p to infinity fp dp. P to infinity fp dp. So this term sine 3t, Laplace transform sine 3t by t, that will give you p to infinity. Then actually the term here will be the Laplace transform of sine 3t. That means 3 by p square plus 3 square. Then dp, that is equal to you can write this is as this 3 is here, and p square plus 3 square, that means x square plus a square in this way, and that can be dp by x square plus a square is equal to 1 by a tan inverse x by a. So you can write this as 1 by p square plus 3 square dp, that is equal to 1/3, since in this case a is 1, so 1/3 tan inverse p by 3, and this 3 is that 3. So this actually the dp by p square plus 3 square, that will give you 1 by 3 tan inverse p by 3. Okay, so the limits are p to infinity, because you know that dx by x square plus a square is equal to 1 by a tan inverse x by a. We have used that formula. So these three cancel each other, and after, if you use the limit infinity, then tan inverse infinity, that will provide you pi by 2. Then minus, if you use p, then tan inverse p by 3. So this is nothing but cot inverse p by 3. So we obtain that sine 3t by t, that is equal to Laplace transform of sine 3 by t. It is 3t by t, that is equal to cot inverse p by 3. So then after that now we have to find out the value of that is we have to compute. So here is that okay, this here so this is here cot inverse p by 3. So then Laplace transform of e to the minus 4t by 4t into sine 3t by t, that is equal to because you know that you just use the first shifting property, that will Laplace transform e to the minus ax fx, that can be written as Laplace transform f of p minus a, where p is the Laplace transform of fx. So you know this formula. This is the first shifting formula theorem. So in this case a is equal to 4. In that sense, you can write e to the minus 4t sine 3t by t, that is equal to here is your Laplace transform of this term sine 3t by t, that is cot inverse p by 3. Here only just you replace this fp by fp minus a. So fp was tan inverse cot inverse p by 3. So here p is your, in this case this a is, this a is minus 4. So in this case, P should be replaced by P minus of minus 4, that is P plus 4. So then cot inverse P by 3, that will provide you cot inverse P plus 4 by 3. That is equal to that is equal to also, that can also be written as tan inverse 3 by P plus 4. So this is the Laplace transform of the function, given function this. Okay. Next, find out the transformation Laplace transformations of the following functions. Number one is 1 minus e to the power t by t, and number two is sine 2t by t. So first one is here Laplace transform of 1 minus e to the power t by t, that we are here to compute, whose value is there we are to compute, that is this function, and the Laplace transform of this function is L of 1 minus e to the power t by t. Now here Laplace transform of 1 minus e to the power t, that is the Laplace transform of this function, that is only this function is here Laplace transform of 1, then minus Laplace transform of e to the power t. You know that Laplace transform of 1 is equal to 1 by p, and Laplace transform of e to the power a t is equal to 1 by p minus a. We have this knowledge. Okay, so here just use the value of a as 1. So using that, we can write the Laplace transform e to the power t is equal to 1 by p minus 1. P minus 1. Okay. Then, so the Laplace transform of 1 minus e to the power t by t, so which has the form 1 by x fx. Okay. And in that case, in that case, the Laplace transform of such function, that is 1 by x fx, is p to infinity, then p to infinity, then fp dp. So here the Laplace transform of this function is this 1 by p minus 1 by p minus 1, and if we divide this term, this quantity by t, and we wish to find out the Laplace transform of that function, then this can be computed as p to infinity, then the Laplace transform of this function, that is 1 by p minus 1 by p minus 1, then dp. Because you know that the formula, what is the formula? The formula is Laplace transform of 1 by x fx is equal to p to infinity, then fp dp. So in our case, the fp means the Laplace transform of the given function. In this case, the function is taken as 1 minus e to the power t, and in that case, the Laplace transform of this function is fp, that is 1 by p minus 1 by p minus 1. That is, we just carried out that. So this is there. So p to infinity, then 1 by p dp, you can write this, then minus p to infinity, and you can write this dp as d of p minus 1. You can write this, because if I come here, you will you will have only dp. So by p minus 1. So this is dp by p, and this is d of p minus 1 by p minus 1. So every each term will give you logarithm result. So from here, log p to infinity, then minus log p minus 1 p to infinity. Just use the limits. There I have done it, and after that, finally we can obtain log p minus 1 by p. So the Laplace transform of 1 minus e to the power t by t, that is equal to log p minus 1 by p. So finally we obtain the result. Number 2 is there. The second one is Laplace transform of sine 2t, and you know that the Laplace transform of the second one is here. Second one was sine 2t by t. So first we will calculate the Laplace transform of sine 2t. So here is that Laplace transform of sine 2t, that is equal to, you know that the Laplace transform of sine x is equal to a by p square plus a square. So in this case, a is equal to your 2. So according to this relation, Laplace transform of sine 2t, that is equal to a means 2 by p square plus a square means 4. So 2 by p square plus 4. Therefore, the Laplace transform of 1 by t sine 2t, that means sine 2t by t, that is equal to p to infinity, then fp means this 2 by p square plus 2 square, then dp. That is equal to, and this has the form dp by x square plus a square. In this case, a is equal to 2. So that will give you 1 by a tan inverse x by a. That means 1 by 2 is here, tan inverse p by 2, and this 2 is here. 2 will cancel each other, p to infinity. So that is equal to, using the limits, tan inverse infinity minus tan inverse p by 2, and that will finally give you cot inverse p by 2. So the Laplace transform of sine 2t by t, that is equal to cot inverse p by 2. Now Another problem is here, find the Laplace transform of ft that is equal to t square and ft that is equal to t cos t by using the transform of derivative. So in this case, you should not use the usual method. You have to use, or you have to employ the transfer of derivative method. So the function is here. The first problem is here. The function is ft that is equal to t square. So here is that ft is equal to t square. Therefore, f of 0 that should be 0 from this relation, and f prime t that is the differentiation of this function with respect to t, that is equal to 2t. So f prime 0 that should give you 0 result, and f double prime t from here that is equal to 2. Therefore, f double prime 0 that is nothing but 2, and from here also f triple prime t that is equal to 0. Okay, we just computed these things, and after that you also know that from the Laplace transform of derivatives of a function, that L of f triple prime t that is equal to p3 L f t, then p square f0, then p f prime 0, then minus f double prime 0. You know this relation, or you have already calculated this. Just you have to recall this or remember this, and you have to go through the previous class. Then it is computed there. So L of f triple prime t that is equal to p3 L of f t minus p square f0, then p f prime 0, then minus f double prime 0. So that is now just use t is equal to 0 in this, since in this expression, so your here f triple prime t is equal to 0 here. So Laplace transform of 0, because we have computed f triple prime t in this here. So Laplace transform of f triple prime t means 0. Okay, that is equal to p cube, then Laplace transform of ft from here, then minus this p square is 0, and f of 0 we have computed is it from here, f of 0 that is equal to 0, so 0 into p square, then p into f prime 0, f prime 0 is here, where that is f prime 0 is equal to 0 here. So p into 0 another from this part, from this term, this is here, and f double prime 0 that is f double prime 0 is 2. So with minus this negative sign is here and 2. So this term and this term, since f0 is equal to 0 and f prime 0 is equal to 0, so this term will give you 0 result, not result. Furthermore, Laplace transform of 0 that is equal to 0, because you know that Laplace transform of constant is equal to c by p. Okay, and in this case c is equal to 0, so Laplace transform of 0 is equal to 0. So this is equal to 0, and this term is there, and this 0, this one is 0, and this is minus 2. So p cube L of ft that is equal to 2, that is here, or L ft Laplace transform of ft that is equal to 2 by p cube, 2 by p cube. Therefore, our function is there, ft is equal to t square. So Laplace transform of t square that is also given here, that is equal to 2 by p cube. So we have computed this Laplace transform of t square using the transform of derivative. So it is also very interesting. Now the second one is here. The given function is ft is equal to t cos t. Here, see here, that second function is ft is equal to t cos t. So that is here. The second one is ft is equal to t cos t, and from here f of 0, from this f of 0, since t is equal to 0 in this case, for this t is equal to 0, it will give you 0. So f of 0, f0 that will be 0, and f prime t that is equal to, just differentiate this with respect to t. So f prime t is equal to, first take cos t is constant, so cos t is here, and differentiation of t is equal to 1, so this is cos t, and then take t as constant, and derivative of cos t is equal to minus sin t. So cos t minus t sin t, this is the first derivative of f prime t of the given function. And from here f prime 0 is equal to, from here f prime 0 and t is equal to 0, this will give you 1, and from here since t is equal to 0, this will give you 0. That means f prime 0 is equal to 1, and f double prime t is also can be computed from this relation, that is equal to, for the first one, that is the differentiation of cos t is equal to minus sin t. Then this will give you t, differentiation of t, first differentiate t taking sin t constant, that is here, that will give you sin t. Then take t as constant, and differentiate sin t, that is cos t. So minus t cos t. So this is the second derivative of ft with respect to t. That is equal to, you can write this, simplify this. This is sin t and this is another sin t, and this is t cos t. So this can be written as minus 2 sin t, then minus t cos t. Okay. Now taking the Laplace transform of the second derivative of ft. So now we are using the Laplace transform of the second derivative of ft, that is f double prime t. That is here L Laplace transform of f double prime t. That is equal to p square Laplace transform of ft, then minus p f0, then minus f prime 0. This is the formula. We have already have knowledge of this. So that is p square L ft, then minus p f0, then f prime 0. Now substituting the values. So first p square L Laplace transform of ft is here, and then f of 0 already computed, f0 is equal to 0. So p into 0. After that f prime 0, that is here 1. So that is minus 1, and that means from here L f double prime t, that is equal to, from here p square L ft, L of ft, then minus 1. So this is equation number 1. I have written this as equation number 1. Again, Laplace transform of f double prime t, that is equal to, already we have computed f double prime t. F double prime t is equal to minus 2 sin t minus t cos t. So using this Laplace transform of f double prime t, that is equal to Laplace transform of this term. So that is Laplace transform of minus 2 sin t minus t cos t. Okay, that is equal to minus 2, then Laplace transform of sin t, then minus Laplace transform of t cos t. Okay, or Laplace transform of f double prime t, that is equal to minus, this minus 2 is here, and you know that the Laplace transform of sin t is equal to 1 by p square plus a square, because you know that sin ax is equal to sin a square. It's a Laplace transform of sin ax is equal to a by p square plus a square. So in this case your a is equal to 1. So that means Laplace transform of sin t is equal to 1 by p square plus 1, and we multiply these two with negative sign, and then minus Laplace transform of and from here that is, you know that this t cos t is nothing but your given function ft, because see here your given function is t cos t, that is ft. So we write it just here in this way, that is minus this L t cos t means Laplace transform of ft, this is the given function. Okay, now this is equation number 2. Now just compare this equation number 1 and this equation number 2. This equation number 1 and this equation number 2, just compare this. The left hand side are the same. So this the right hand side, and this is also the right hand side. These two terms are equal. So that means minus 2 by p square plus 1 from here, then minus Laplace transform of ft, that is equal to from here p square Laplace transform of ft minus 1. Just now take this Laplace transform of ft in the right hand side, that is p square plus, and then take L Laplace transform of ft as common term, then from here 1 and from here p square. So p square plus 1 Laplace transform of ft, that is equal to this minus 2 by p square plus 1, and this plus 1 is here, that is equal to p square plus 1. Just to simplify it, then minus 2, then plus p square plus 1. So from here Laplace transform of ft, that is equal to from here p square minus 1, and this p square plus 1 is here. So this is the value of Laplace transform of the given function ft, that is p square minus 1 by p square plus 1. So it is also interesting, and this is another way to find out the value of the Laplace transform of a given function using the Laplace transform of derivatives. So the next one is here. The next one is another problem, that is evaluate the integral 0 to infinity t e to the minus 2t sin t dt. Okay, so let I is equal to 0 to infinity t e to the minus 2t sin t dt. So that can be written as 0 to infinity. This e to the power minus 2t I am writing is at e to the power minus pt, then t sin t and dt. Obviously in this case p is equal to 2. P is equal to 2. And according to the definition, you know that this is nothing but Laplace transform of t sin t. Because you know that the Laplace transform of a function fx is equal to 0 to infinity to the minus px, then fx dx. Here the function is t sin t. So this is nothing but the Laplace transform of t sin t. Obviously in this case p is equal to 2. So now you know that the Laplace transform of sin t, that is equal to 1 by p square plus 1, because the Laplace transform of sin x is equal to a by p square plus a square. So in this case a is equal to 1, so this is equal to 1 by p square plus 1. And also you know that Laplace transform of like this t sin t, t sin t, that would be or this has the form x sin x, that is equal to actually nothing but minus 1 to the power, that is it has the form x to the power n sin or fx, because this I am writing this is like the form Laplace transform of x to the power n fx, and the value of that is minus 1 to the power n, then dn dp n fp. fp means this. fp means the Laplace transform of the function. So t sin t, that means in this case the power is n is equal to 1. So minus 1 to the power 1, that means minus, then ddp of the Laplace transform of this function, that means 1 by p square plus 1. So that means ddp of 1 by p square plus 1. So that is here. So negative sign will be here, and this means p square plus 1 to the power minus 1, and that will the definition of that will be p square plus 1 whole square, then minus 2p will be there, and another minus here, so plus 2p by p square plus 1 whole square. And you know in your case the value of p is equal to 2, just substitute the value of p is equal to 2 in this expression. So this will be 2 into 2 by, from here 4 plus 1 whole square, that means 4 by 25. So the given integral, that is 0 to infinity t into the minus 2t sin t dt, that is equal to 4 by 25. So in this way we can use or apply Laplace transform to compute different kind of integrals which would be very difficult to solve in usual method. So this is the end of this class.